When checking your polypeptide, the first thing that you want to look at is the backbone of the molecule. This might be all jumbled up, but you can actually make heads or tails out of it by unfolding it and finding that backbone to the polypeptide. The first thing I'm going to do is identify the amino end. And once I've identified the amino end, I just follow the backbone with NCC, 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 NCC. And then this is the carboxyl end. So once again, I have the amino end here, the carboxyl end here, and the backbone of NCC, 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 NCC. Now when you do this, the R groups become apparent. This is the first R group here. Here is the second R group of this polypeptide. The third R group is here. And the last R group is right here. Okay, the next thing that you can check is what's attached to the various atoms in the backbone. So if we start after that first amino group and we go NCC, from that second carbon you should see a double bond to an oxygen. And then NCC, you should see a double bond to an oxygen. NCC, and see the double bond to an oxygen. And finally, you can look at the nitrogens. So here's the amino end again, NCC. Here is the, should be on there, here is the nitrogen with a hydrogen attached to it, NCC. Here is the nitrogen with a hydrogen attached to it. And then here's another CC, and then nitrogen with a hydrogen attached to it. Now, while you constructed this polypeptide and forming the peptide bond, you removed basically 2 hydrogens and 1 oxygen for the formation of each one of those peptide bonds. Those can be reconstructed as shown here. And so you have 3 water molecules that you should have been able to produce from the formation of the 3 peptide bonds between the 4 amino acids in this polypeptide.